Hello, everyone. So my name is Mike Gelzer. If you are a particularly interested in Filecoin retrieval markets, you're in the right place. If you want to get involved with any of the projects, you're in the right place. We had a discussion on Tuesday night U.S. time, it'd be Wednesday morning, China, Asia Pacific, and middle of the night on Tuesday in EU. So I know some people could make it, some people couldn't. If you couldn't make it, let me just actually, hold on. I'm just going to give you this link in the chat. These were our presentations. This was not a particularly interactive session. What I would like to do with this one is make it a really interactive session. Yeah, and so just seeing the questions in the Slack. Yeah, I think we can use voice to answer the questions. I would say don't interrupt a presenter, but as soon as they finish, it's fine to jump in with questions. I think this is a much more informal. The goal is to share knowledge so that more people can get involved in the community. So we don't want to squelch anyone. So what I was just going to do a highly abridged version of what I said on Tuesday night, and then I was going to turn it over to Peter, who I was hoping would do the same, and Thomas and David, if they're here. I was thinking we just like 2 minutes each or something, and then that just sets everybody's on the same page at that point. Like you know what we do, even if you've never done any retrieval market stuff before, and then we can just go into a discussion. Really briefly, the original Filecoin white paper had these two concepts. There's a storage market and a retrieval market. And the storage market is the thing that was launched last week. That's the sort of the crux of the whole idea. The retrieval market, though, has a different set of goals. It's intended to make retrievals fast, low latency. It's intended to let anybody become a retrieval miner without necessarily having 6 GPUs and an entire data center or something like that. So that's kind of what the goal of the retrieval market is. It's not super well specified, which I think is intentional. And so we've got 4 different teams who've been working over the summer on projects that are taking this basic idea and sort of looking at it from different angles. Consensus that's up here. He's going to present on the architecture for the retrieval market. I can just briefly describe the browser-based retrieval client. Thomas for a mile, if he's here, I can't see who's here and who's not, would present on what he's doing, which is basically a retrieval client as a desktop application. And then David or Elizabeth from ChainSafe could also do 2 minutes on what you guys have for your gossip-based retrieval market. So that's what I was thinking of for this evening, and then the rest of the time we would spend chatting. So without any further ado, I stopped sharing my screen. I'd like to turn it over to you, Peter, if you're here. Yeah, you are here. Oh, okay, Robert's here too, great.
Yeah, Robert's here too. And so I'm going to compress 10 minutes into about 2. So so we're doing a secondary market retrieval solution. And so the primary retrieval market was all about Lotus nodes connecting to storage miners. And so we wanted to, have something that's discoverable, in-network caching, low latency, and massively scalable as well. And there's an incentivization scheme to be involved in the discovery of content and retrieval of content. And so we came up with a massive overall architecture where you've got a library and that you can integrate into applications, and it helps you find content. And so you have a PCID and a CID, and that will be what you need to find any content in the system. And the idea is that you have offers, and an offer is a fixed price offer for a certain retrieving content. And they're published by these providers. And initially providers are just linked to storage miners, but you could have them in network as well. So offer gives you the cost of the content, the expiry date when the offer will cease, and maybe some quality of service metrics. And why this is a good idea is rather than having to have 2 round trips at least to find any content and get a deal on it, you can just talk to one entity in the system and it will be able to give you an offer immediately on content. So it should be lower latency. And so the idea is you've got these gateways in the system and you might have payment channels set up with a couple of them, and then they will give you offers. And so your client ask multiple gateways as well. If a gateway doesn't have a CID offer that you in particular need for your CID, then it will use a DHT. And so we've got to come up with a very special DHT, which is different to most DHTs you've ever come across, because it's using the fact that you've got stable nodes that are long-lived and to give you single hop lookup. So it's again aimed at low latency, but full coverage of all the PCID range. And as I said, there's also the idea of in-network caching. Payment brokers is another idea so that you can do payments. And then there's an idea of a subscription service. And so that is me done. So our solution in about a minute or two.
Excellent, excellent compression ratio. That was very good. Thank you, Peter. So let me see. I want to go next to David from ChainSafe, and then, yeah, then let's just go into kind of an open discussion. So David, can you kind of do a 2-minute overview of what you guys have built? And
yeah, certainly. Let me just throw this up. Basically what we've done is we've taken some of the existing Go tooling for doing retrieval, and we've attempted to establish a fairly simple gossip mechanism to allow discovery of data within the gossip network. And this is definitely, I mean, we're definitely limited by some of the existing tooling and the way it's kind of integrated with Lotus. But this is a good platform to really start to explore some of the potentials of what retrieval markets can look like, and kind of provides a nice entry point for developers to start playing around with this stuff. And so we definitely want to continue this and make it much more usable and kind of readily available for people who want to start playing around.
Okay, great. Thank you for that. Sorry, I almost forgot the project that my team has been working on. So let me do my 2-minute spiel, and then we can just have an open discussion. So I gotta get back to screen share. Okay. All right. Do you see a title slide? Someone say yes.
Yes.
Okay, thank you. Okay, just making sure. Okay, so just to condense this down to 2 minutes, what my team's been working on over the summer is a browser-based retrieval network. So this is a screenshot of what it looks like. Oh, and of course, this is the repo. I think over the course of the summer, we've had about 10 contributors. There's probably 5 active people right now. But instead of trying to show you a demo, which would take beyond the amount of time I have here, I would just show you, this is a screenshot. The idea is this is running in your browser. You can put a CID into this query box, search for it. You'll get all of the offers from other instances of the browser extension. So all of the browser extensions form a peer-to-peer network. You can see at the time this shot was taken, there were a total of 3 on the network. It's just a testing network. And then you can buy a CID from another browser extension, and a payment channel will be opened, and you will exchange data and sign vouchers with the other browser, just according to the regular Filecoin payment channels protocol. And you will end up with the content, and the provider will be paid. And this is what it looks like when you have a CID that you've already purchased. So if you want to, so here's a video of the actual demo. It walks through a little more detail. It shows you what's actually happening in the logs. So that's one thing to check out. And also I just remind people, if you're watching this and you don't have any previous exposure to retrieval markets, this is the place you want to go. This was the discussion we had on Tuesday night. So that was all. Oh, I want to say one brief comment about this. Just I think this diagram might make it a little clearer. And I do think that this architecture is basically the same as what Thomas is using. He's not targeting the browser as his deployment platform, but it's the same. He's using basically the same concept. So I think this is applicable also to his. He couldn't be here tonight, but so like I said, the browser retrieval clients, those are the green boxes. They form their own peer-to-peer network. So so there's like a retrieval network of just purely retrieval nodes, and they can they can retrieve a CID from another. That's what I walked you through in the last slide, and they can also provide their CIDs at whatever price they want to price them at to the other browsers. And then you see on the right-hand side is the Filecoin storage network, and there's a little white line between the green and the yellow parts, and that is the notion that the browser clients can also make a retrieval request from a Lotus storage miner. So if a particular CID doesn't yet exist in the retrieval network, there is a means to get it from what you might call cold storage and thaw it out and bring it into the browser network. So with that, I want to stop and see if anybody has any questions or comments, or I want to get involved, or I want to go in a completely different direction. Any of those would be great. And David, are you watching the YouTube? I don't have that in front of me.
I am.
Okay.
I'll let you know if something comes up.
Yeah, thanks.
So Alessandro, how are you? And you're, as far as I know, you're the only one on the call who's not directly involved. So hence, what are you thinking about, when you're hearing all of this?
Yeah, this is awesome. I'm super excited about this. I was also really hoping that there would be some browser-based retrieval market stuff, because it's just where I imagine ingesting a lot of information and playing with it. I was curious, so if it doesn't use a Lotus node or like a client that is directly running on the host's computer, how does it actually tap the network, and how are payments handled and everything like that? Is it like similar to like a MetaMask where it's tapping out, it's like a light client kind of thing, or how does that work?
Yeah, I mean, I can take that one. So if I sorry, let me go back to sharing my screen, and then I'll share a window that isn't just slides. So here's what the browser client that we've built so far looks like. And I've got two instances of it running. One's in Chrome, one's in Firefox. The Chrome one has a CID in it already. So it's like, that CID. Yeah, go ahead.
Sorry, is that stored in your browser's local storage? Just because
Yes.
Okay.
Yeah, it's stored in the browser's local storage. So if you want to get it onto your desktop, you actually have to click a second download button. But this is just a local download from your own machine.
Cool.
But the way the transfer itself works is first you send out a query for the CID. It goes to every node in the network. Right now there's only one other node, which is the Firefox. So of course it only gets one reply. That's the price. So I'm going to click buy. And now there's going to be a long process where both browsers, this one is providing the data, this one is sending the data. And
it's the same assumption as Peter's system, where there's existing offers at a set price, right?
Yeah, exactly. Yeah. I think the biggest difference with Peter's system is that they're trying to design an architecture for low latency retrievals, whereas as you're going to see, we could talk about this for the rest of for the next probably 2 to 3 minutes, and this 4 kilobyte file will only barely have finished transferring. So I wouldn't exactly call that low latency. But you can see all the stuff that's really going on if you go into the logs on the two. So this guy, the requester of data, sets up a Filecoin payment channel. So where does he do that? Create payment channel. He submits a message onto the chain. I'm not going to walk you through the whole execution trace unless you really want, but it goes. The two of them do the dance of the whole exactly the same way that one Lotus node would retrieve from another.
Is this a full browser-based wallet and node that's able to reach out to the network directly?
Yeah, well, sort of. Okay, so you have to put in a wallet, and obviously you have to put in the wallet's private key. The reason is all of the messages you're going to publish on chain are signed locally here in your browser. And then they're pushed out to a public cloud Lotus, which is just like, it's a Lotus instance where you can publish messages on the chain, but it doesn't have your wallet. It doesn't know anything about you. You're anonymous. You're just trying to get a message published on the chain.
That would be like the equivalent of an Ethereum Infura node or something.
Exactly.
Like
Yeah. It's the Infura model. Yeah. Yes. Yeah. So this isn't trying to be a wallet, and I think it might work better with something like MetaMask or supporting like Ledger hardware wallets, or. But this is just the design right now to make it work at a fundamental level. And yeah, so on this instance, the Chrome one that's doing the download, the wallet is the one, the payer. Funds are coming out of this wallet, and then this guy also has his own wallet, his own private key, and he will be the recipient of the funds.
That's super helpful. Thank you. That's
How
rad.
do the two nodes, or say the nodes on the network, do discovery? How do they find each other, or the other nodes on the network?
Yeah, they use libp2p's WebRTC. It's a separate package that you can install within JS libp2p, and it's just and then we run a WebRTC signaling server. It's like the rendezvous point, and when they start up, they all connect to the signaling server. It informs them of how to connect to each other, and then after that, it's a direct connection between.
Yeah. Okay. So you've got it. So it's sort of like a single boot node, so a single point of failure. It
is possible to run multiple boot nodes. It's just for this, at the level of maturity that this is at right now, I didn't feel it was necessary to.
Yeah, fully understand. And I think, this is, so we thought about, using an RPC mechanism, in the boot nodes or something for Filecoin for our system, and ended up saying, look, we'll use smart contracts. So, and whether they be Ethereum on Ethereum mainnet or on Filecoin mainnet, will depend on when the EVM is up and running on Filecoin. But yeah, and the reason why we ended up not going with RPC was we thought that it meant that those boot nodes would be potentially hammered, and also a DOS attack point as well. Whereas if it's in a smart contract, then you're just attacking or talking to your local node with its local copy of the distributed ledger. So that's how that's how we got to where we got to with how to do node discovery.
Yeah, that's really interesting. So libp2p has a little bit of a defense against this built in. If it can connect to the WebRTC server, then the first thing it does is try to download as many peers as it can, and those go into like a local peer store. So then if the WebRTC rendezvous point is knocked off the internet, you still have these other local peers, and you can use them to get to discover other peers on the peer-to-peer network. And this is all like built into libp2p. This wasn't invented for this extension, but it was part of our sort of robustness goal for libp2p, that libp2p network should be very resilient. You shouldn't be able to just knock them offline. Of course, everything has, some spots are softer than others. But that was really the goal of libp2p. And we've gotten very good results with it from IPFS, from Filecoin so far. And Ethereum 2 is going to use libp2p in their launch, which I believe is coming later this year. I know it's been much delayed, but I believe they're serious now. So I don't know, you guys might want to check out libp2p as you get to the implementation stage and see if it's better than trying to reinvent the wheel.
Yeah, sure. Sure. Well, it's just, as much as anything else, we didn't want to put more burden on the Filecoin boot nodes. I remember we had that conversation with Juan where we were saying, so how many CIDs are out there,
Yeah.
And I think it was funny. Just before the meeting, I'd said 2 to the 60, and then I think we got to 2 to the 60 after a bit of a conversation. So, which was a good confirmation. So, how in a browser-based solution, where you're doing browser-based retrieval, how many CIDs and associated content are you going to be able to have sitting in the browser? And,
Yeah, so not 2 to the 60. The thought with the browser application is kind of three goals with it. First of all, it's not meant to be it's not meant to move large amounts of data. So the one use case is just a user wants to retrieve something from Filecoin. So she loads up this browser extension, or we may turn into a website, but one way or another, the user loads this up, types in the CID of interest, and just finds that. And then once the file is downloaded, that person may disconnect and just use the file locally, like, mission accomplished. The second goal, and this is the one that would push scalability, I think, a little bit more, is people who want to be retrieval miners in the browser may want to run a browser extension that is storing a long list of CIDs. And we talked for a while about, well, what CIDs exactly would they be storing and why. And our thinking is a lot of CIDs are going to be auto-generated. Like, it may be every time this certain software package gets updated, it's going to be pushed to Filecoin. There will be a new CID for it, and a clever miner could take this browser code and basically automate it to always check for that, and then be the lowest cost provider of whatever software package update. And so I don't think we're going to get browser retrieval miners who just want to mine every possible CID and provide them. It's just not realistic.
It's not possible.
Yeah, it's not possible. Yeah.
I mean, by the time it's just too much content. Yeah.
I'm just looking at Robert's comment. I do know Web3 torrent. Sorry, let me read. Oh, interesting. Okay.
Yeah, so they definitely, we do have, in sort of our final report is, and we'll go through that with you guys, some thoughts about what sort of ongoing scaling on the payment system is going to be needed, because right now the payments on the retrieval payment channels are competing against the storage deals, whereas the volume of the retrieval to storage deals may be, many orders of magnitude higher on the retrieval side. So we need to offload this with some layer 2 systems. Both state channels and roll-up systems are likely going to be needed. One thing that I thought would be interesting to share, we've also given you guys, Mike, a finalized version of a document that this table comes from. This is a table that I did some analysis early on, looking at what sort of the objectives that we're trying to get. And part of what we focused on, part of the reason why, what Peter put together with the Ring DHT and the two-structured system was that, we looked at what does it mean to actually have a retrieval system. And, Juan has showed this diagram. Hold on, let me actually bring up the diagram that he shows from his presentations sometimes. And it's this one, right? And it's sort of a nice graphic. It shows like, okay, here's storage miners, here's retrieval miners. This is what the cost and the capacity look like. And, you see these kind of dotted lines that are Glacier, S3, and CloudFront. And they're referring to the, most prevalent cloud distributed storage system that everybody uses, which is Amazon S3. And so, we started off our project. We didn't kind of jump into coding. As you guys know, we were doing the architecture work. And, this sort of was my best, because Amazon has the information at the bottom is not something you just find in one spot for Amazon. This is like a collection of 2 or 3 dozen documents pieced together and other things. But, I was trying to put together an idea of what do those kind of different levels of storage look like. And it was useful, I thought, to actually show like cold, warm, and hot. And actually, Mike, right before our session yesterday, the guy who won the Space Race Challenge, right? The miner who won that was actually talking, and he made a comment about this, which is correct, which is that, the Filecoin system without a strong retrieval system in front of it really is very much like Glacier. It's cold storage, right?
Yeah.
And so what you need to do to actually get it, it's not coldest, right? The reason why for Amazon, Glacier Archive and Glacier are kind of like this coldest storage is they're actually on tape. And tape takes many minutes inherently to unpack. And of course, we know with Filecoin, it's on hard drive, so you can retrieve it, in seconds, right? It's a very quick retrieval in theory, assuming you find it, negotiate the payment and everything else. So, what Peter's described in the architecture that really does, I think addresses this is recognizing if you want to get to the range of S3 and CloudFront, you don't have the time necessarily to go through a large multi-hop distributed hash table of the type of Kademlia or others where there's very kind of low radix, where you only have 6 or 8 neighbors and you may go through many, many hops in order to get there. You need to both discover who actually has the file that the CID points to, and then you need to connect with that person, which in Kademlia is actually 2 different lookups. You do one lookup of CID to provider, and then the second time you have to look up where in the network is the provider. You go through the overlay twice. So that's why the architecture was very much of this kind of, what could get us into this S3 and possibly even CloudFront of, 1 and 2 hop latency and allowing us to, look at things in a close geo region. So the Ring DHT, when Peter shows it, it has kind of a key idea in there, which is, because when providers are looking at where they want to be in the network, they're finding, hey, I see parts of the Ring DHT right now that don't have a lot of providers covering it. So I'm going to insert myself into this part of the network where there's kind of low density. And if you add in looking at latencies, you can also say, oh, there's not a good provider in this part of the network in Australia. There's a bunch of good ones in Europe, but if I sit myself in Australia and there's a good, retrieval flow coming through, I'll make money. So it's really kind of looking to drive incentives for the network to get stood up in the right direction for this 1 or 2 hop latency. And there's a lot more work that needs to be done, but it's trying to kind of do that first step in that direction. Because like you were saying, Mike, we're going to want to be able to compete against Amazon S3 in order to make Filecoin, super useful at this like zettabyte scale.
Yeah. One thing, by the way, good to see you, Hannah. Thanks for joining. I just want one thing in response to that is the way I've kind of been thinking about this, and I mean, none of this is like decided yet or whatever, but the way I've kind of been thinking about this recently is that whatever architecture you guys from Consensus end up, building, implementing an MVP of whatever, so the browser client, as long as I have anything to do with it, I would want to adapt it to that, because I'm really just a poor UI layer on top of Filecoin payment channels. So if your architecture comes along and kind of revolutionizes what, how retrieval works to the point where maybe I don't have to work with low-level payment channels all the time, I just update it to work on your stuff. And I was sort of thinking, David at Chainsafe, you would want to do something similar. Like if we had a whole retrieval infrastructure, you would want to leverage that. And I'm guessing, I don't want to put words in your mouth.
Yeah, absolutely.
Yeah. Okay. So I think we are sort of more the user side. Like we're trying to provide something right now. We're trying to provide something kind of quick and dirty for users. It could get much more usable in the future. But at the end of the day, we're trying to be the user side, not the infra side. And I think you guys are trying to be the infra side, and then you're not going to build a UI or desktop app or whatever. So that's how I've been looking at it. And,
and I think sorry. All right, sure. I think we need both. I mean, when I look at, we've all used Google Drive and how you can just drag and drop, and we need that sort of stuff, the whiz bangery of it all. But yeah, I think it's going to be awesome when the infrastructure's there and the UI is there, and it's all just working really well. That'd be really cool.
Yeah.
Anyway,
yeah.
sorry, Robert.
Alessandro brought up this great thing of the Web3 torrent that the State Channels team had done. Currently, the State Channels team at Consensus has been working with the Graph on a crypto payment system around the Graph indexing retrieval, and then doing very, very efficient server wallets that can kind of do 3-party payment brokering. So that's another part, which actually, you have sort of this client-side browser infrastructure, you have this infrastructure around discovery and kind of finding the deals, and then you have this thing about making it happen. And so that's the part where Web3 Torrent, was sort of a payment system before actually the Graph server wallet came out. I can definitely see there's a scaling version of that because the payment system on Web3 Torrent was just kind of sitting on top of the BitTorrent or the WebTorrent, JavaScript version of torrent infrastructure, and it can be lifted and moved over onto, your infrastructure inside of the network, utilizing the gateways as a lookup mechanism, and then a payment through, payment server providers. So I think there's a good kind of place we can, map out a roadmap for us to put these things together.
That makes a lot of sense. Yeah. And I like Ethereum state channels a lot. I think I've looked at ways to incorporate that into this work. It didn't really make a lot of sense this summer yet. I think it was more just like, I need to get some kind of an MVP that it is workable, usable enough that people could try it. But yeah, I think it's
and the payment system in Filecoin is it's a solid payment system, right? And having the channels and being able to do a receipt, claim or redemption on close a whole bunch of channels at the same time it's a nice design. So the state channels guys did an analysis of it. There'll be extensions and some swapping because state channels have gone a lot farther in terms of what you can do inside of them. But it definitely serves what it needs, which is to get Filecoin going. So.
Yeah. Hey, Hannah, I just saw your comment. So we didn't get a big audience of people coming to ask questions. So then we just started talking to each other.
No, it's cool. I mean, this is a group to chat with each other anyways.
Yeah.
Yeah, I was curious. I have a question. So, well, first of all, I don't know if I get the sense that we're always on the verge of doing that thing that you want, Mike, where essentially remote signing, delegated signing of things that would allow you to use the whole Lotus API as opposed to just mpool push message.
That make my life a lot easier. But
yeah. I'm curious. The other thing that would lower the barrier to entry a lot. The other thing is I'm curious. Do you guys? I think. Well, I guess Chris Chapey is implementing GraphSync in JavaScript, which I mean, I wrote the GraphSync. I like it. I think it's a super awesome protocol. It's also pretty complicated to implement, as is the data transfer. And I wonder if there's some way we can delegate that work as well, so that it's not, I don't know, so that it's not a requirement to have all that stuff set up to in your own language in order to use
that's
it.
interesting.
So, I don't know.
Yes.
Yeah.
So
I mean,
yeah.
Sorry, go ahead.
Well, I was going to say.
I was going to say,
yeah.
written in JavaScript, right? Because it's going to be everywhere. But yeah, but still.
We've looked at a few different options. One is compiling the Go code to WASM. So Jim Pick is actually the one working on that, and he could compile all of everything, including Go data transfer and Go GraphSync, or he could compile everything but Go GraphSync and then call out to the JS version of GraphSync. I want to ask, because there was something you said and I didn't understand which way you meant it. Are you saying that we should consider possibilities for ways of transferring data that are unrelated to GraphSync, or do you just mean we should consider possibilities of transferring data that are using GraphSync but don't require it to be re-implemented in every language?
Yeah, I think probably mostly the latter. I mean I think it's fine to consider others. The biggest challenge with other systems is that you need to be able to verify incrementally, right? You could, but I mean, you could honestly, for example, you could run retrieval on maybe on top of BitSwap. It's a little tricky, but actually, that's not you could write the data transfer module to work with BitSwap, and then you could run it on top of BitSwap, which I believe there's a JS implementation for.
There is.
It's been a bit.
JS.
Yeah. So I mean, yeah, it'd be slower, but that would be one option. As long as you can write and data transfer in theory, the whole design of the module is like abstracted from the underlying transport protocol, which seems
Yes,
to
I
me
know.
to be a little bit ridiculous.
But yeah, no, it
Because
does.
obviously,
Yeah.
a transport protocol is totally a clean abstraction. Like,
No, I know what you mean. I mean, I think so one factor is Juan really wants everything to be graph sync based, like all transfers to be graph sync based. So that was why he asked me to do it, and then I started looking into it, and I was like, we don't even have a JS implementation of that, so we'd have to be compiling Go code to WASM, and
Yeah.
I've already got other WASM binaries, and so then I just went to Chris and I was like, hey, do you want to work on this and create us a JS graph sync? He was like, okay, yeah, great. So that's where that is. Another factor I think is graph sync is faster if there's an element. Tell me if this is correct, because I may be wrong. I believe graph sync is faster if there's an element of oh, I see we're at overtime.
what?
I see we're overtime. Well, here, I'll just ask this last question, and then
Yeah, go for it.
but anybody has to drop off, feel free. And thanks everyone for coming. So GraphSync is faster if there's an element of deduplication that's happening, and that you end up transferring less data. But if it's just a one-shot retrieval, like I want to retrieve entire CIDs, not IPLD selectors, not like an aborted transfer, and I just need to get the second half. It's just like the whole CID, and it succeeds or fails like atomically, basically. In that context, I don't think GraphSync would necessarily be faster.
Well,
Is that right or wrong?
it actually may be. There's specific. Usually, when you say like the whole CID, you're not talking about the block, just the block that CID points to, because that CID is a whole graph of blocks and CIDs.
Yeah.
And if you're using BidSwap, what you're going to have to do, because you don't know the other CIDs ahead of time, and you have no way of expressing that you want, like, I want the whole graph of things underneath, you're going to end up doing a whole bunch of round trips where you're like, give me the first block. Okay, I got the first block. What are the links in here? Give me the next blocks. You know, and essentially, it's going to be it's not going to transfer more or less data, but it's going to take longer because you have to make a bunch of round trip in where you're blocked, essentially waiting to get the data back.
Yeah, that's a good point.
Yeah.
I hadn't thought about that. That's a good point.
So that's actually honestly the main speed advantage of GraphSync for point-to-point transfer. BidSwap is in some cases is better for like a multicast. Like I'm asking 15 people for this thing, which we're not attempting to do with retrieval yet at all right now. So in Filecoin's context, GraphSync is much more ideal.
Yeah, I mean, I remember, Anna, that I was a little, I saw that Netflix at the last IPFS camp or whatever, they were using BidSwap because they were sending around 4 gigabyte, large images, and they were doing the multicast, and they were looking to sort of have the network kind of self-torrent, and BidSwap can work well in that case.
Yeah, it can. For point-to-point, honestly, you're going to be doing payment channel, like sending back and forth payments, and, there's a lot of reasons that will slow it down a little bit more anyway. So I don't know if the difference is that big. It's the type of thing you would find out if you ran both in practice in the same situation.